Okay, good morning everyone. In the previous classes, we have already discussed about the DFA and NFA. Also, we have discussed the NFA to DFA conversions by using two different methods. One is subset construction method and another one is lazy evaluation method. Hope everyone has understood those two methods also, and I have given a few problems based on these concepts. Hope all of you have completed those things. If you are not finding any right solutions, you can just ping me up. I'll find the best solution for you guys. So next concept is about Epsilon NFA. We call it as Epsilon NFA. So all of you are aware what is NFA, right? NFA, which is also called as NDFSL. So NFA stands for non-deterministic finite automata or non-deterministic finite state machine. Right? Here, a transition with the empty input string is called as epsilon transition. Right? Clear? So epsilon transition andreno. So epsilon transition, or sorry, epsilon NFA is a transition with an empty input string. The empty input string. So input string with some alphabets have some transition. Input string. Right? So empty input string is called as epsilon. It is termed as epsilon. Any transition from state 1 to state 2 upon empty input string. So empty input string can be represented as epsilon. This is called as epsilon transition. That is, there is no input string. There is no input string. But transition happens between two states, 1 and 2. Transition from state 1 to state 2 happens without any input string. That particular transition is called as epsilon transition. Is called as epsilon transition. So any NFA with epsilon transition is called as epsilon NFA. So if in an NFA there exists a transition from a state 1 to state 2 or state 1 state to another with no input symbols, that is with epsilon as an input string, then it is called as epsilon NFA. Right? This is called as epsilon NFA. This is the normal understanding of a epsilon NFA. So terminally, how we can define a epsilon NFA is that, so again here NFA is a 5 tuple, right? Similarly, we have epsilon NFA also with the 5 tuples. Epsilon NFA with the 5 different tuples. So again here the first is K, that is finite set of states. Next is alphabet symbol, the input symbols, and next is what we call transition function. This is accepting state and the start state. The same way, but here in your alphabet set, we have epsilon by default. Epsilon by default. This is your epsilon NFA. Here K stands for finite set of states. Finite set of states. This is alphabet set. Alphabet set that includes your epsilon transition function. Transition function is K into alphabet set union epsilon to K. That is alphabet set along with your epsilon. That is to map into your finite set of states. That is your transition function. And this A stands for accepting state or final state. Accepting state or final state. S stands for start state. stands for start state. Okay, let us see one example which mentions this note very clearly. So any NFA with epsilon transition is called as epsilon NFA ಅಂತ ಹೇಳುತ್ತೀವಲ್ಲ ಅದಕ್ಕೊಂದು simple example ತೆಗೆದುಬಿಟ್ಟು ನೋಡೋಣ. So what is that simple example? I'll draw three states. I'll call state 1, state 2 and state 3. And in this I'll make 3 as my final state. This is my start state. And input symbols I take as A comma B and also epsilon because it is a epsilon NFA example. So epsilon will be default input symbol for my transition. So here I take first I'll write what I'll call it as just I'll draw. I'll write over here transition table. I'll write. So I'll take epsilon A, B states are 1, 2, 3. So this is my start state. This is my final state. I'll make so 1 on epsilon. So 1 on epsilon. So 1 on epsilon without a input string. 1 can move on to 2, right? So 1 on A, I'll move on to 1 itself. So 1 on A, I'll also move on to 2. So 1 on B, there is no transition. I'll take none. Next, 2 on epsilon, I'll move on to 3. 2 on A, null. 2 on B, I'll move on to 2 as well as 3. 3 on A, 3 on epsilon, 5. 3 on A, 3. 3 on B, 3. So for this, you try to write a transition diagram for this particular example. So 1 on epsilon. So 1 upon epsilon, that is without transition, without input symbol, it is moving on to 2, right? Similarly, so 1 on A is moving on to 1 as well as 2. So 1 on A is moving on to 1 as well as 2. So 1 on 2, so transition from state 1 to state 2 can happen in two manners. Either input symbol is nothing or input symbol is A. If input symbol is nothing also transition can happen. If input symbol is A also transition can happen from state 1 to state 2, right? Similarly 2 on epsilon is moving on to 3. 2 on A it's moving on to null. 5 is the null, it's not having any transition. So 2 on B is moving on to 3 as well as B. Next 3 on epsilon null, ಏನು ಇಲ್ಲ. 3 on A and B is having the right. So transition from a state 1 to state 2 can happen even without A. It can happen without A, that is epsilon, without input symbol it can have. So 2 again it can have transition to 3 without input symbol B. If input symbol exists and if required, I can use it. But without it also, it can move from a state 1 to state another state. That is called as epsilon transitions. Clear with this? Okay. So for the same example, let me define this particular alphabets. Definition of a epsilon NFA. So we'll define it. Finite set of states. Okay. How many states? 1, 2, 3. One set. Empty set. 1, 2, 3. 1, 2. 1, 3. 2, 3, right? These are the final set of states. Next is alphabet symbols. So alphabet symbols, epsilon, A, B. Transition function, that is K into epsilon union alphabet set to K. Next, accepting state, which is my accepting state, 3. Starting state is 1. Right? This is how you define your Epsilon NFA. You can have these many types here. Right? So for this, you can write your transition table like this. Clear with this? So in an Epsilon NFA, there can be 0, 1 or more transition with or without your input symbols. So with or without input symbols, you can have transition from one state to another state either individually or multiple. I can have transition from state 1 to state 3 with epsilon. I can have transition from state 2 to state 1 with epsilon. There is no problem. Epsilon transition can happen between any states without any input symbols. That is your Epsilon NFA. Right? So to solve a problem regarding this particular Epsilon NFA, you need to first know the concept of E-closure. So first we'll try to understand the E-closure, then we'll see the theorem algorithm for this conversion of Epsilon NFA to DFA, then try to solve a problem. First we'll try to know what is E-closure. E-closure. The E-closure of any state Q is a set of all the states that are reachable from a state Q on epsilon transition only. So E-closure is a concept or state from a Q, from a state 1 to any state which it can easily reach directly or indirectly with a epsilon transition is called as E-closure. So E-closure compute ಮಾಡೋದು ಹೇಗೆ ಅಂತ ನಾವು ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡುವಾಗ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಬಟ್ E-closure ಏನು ಅಂತ ಇಲ್ಲಿ ಬರೀತೀನಿ, ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. The E-closure of any state, E-closure of any state Q is the set of all states that are reachable from a state Q on epsilon transition only. Epsilon transition only is called as E-closure. Is called as E-closure. Right? So this E-closure is required when we are supposed to convert your Epsilon NFA to DFA, its equivalent DFA. ಅವಾಗ ನಮಗೆ ಇದರ ಅವಶ್ಯಕತೆ ಬರುತ್ತೆ. So before going to that, what we'll do is first we'll try to understand the first problem of your how to generate your Epsilon NFA. So by using one of the simple example, that's quite enough. We'll have one problem to solve or to generate your Epsilon NFA. Define epsilon NFA, which accepts a strings which consist of 0 or more A's followed by 0 or more B's. Right? So the question is that take down this problem first just to understand your epsilon NFA. Epsilon NFA problem. Just a simple problem. Just you can once you understand this problem, it's very easy to analyze what is epsilon NFA. So write down epsilon NFA that accepts a language with strings that are strings with zero or more number of A's followed by 0 or more number of B's. So we are going to write a language that accepts strings with 0 or more number of A's or 0 or more number of B's followed by 0 or more number of C's. Followed by 0 or more number of C's. 0 or more number of C's. See here, understand the question. With 0 or more number of A's, so A can be a number or they may not be there at all. But after A, it should be followed by n number of B's or they may not be, followed by C. So C also n number of C's or may not be there. So it can have A, B, B, C, C, C. So next A, B, C or B, C or B, only C or only A, or it can have nothing, right? Or even it can have epsilon. So now try to solve this problem by the method we have already seen earlier. So step 1. What is my step 1? I need to find a language L which can be accepted by this particular program, right? So all these things are my languages. So I'll write A. First I'll write epsilon, B, C, A, B, B, C, A, B, C, so on. Okay. Next step 2. Negation of language. So negation of language nanu em baribodu? So nothing. Everything is accepted. F5. Enu ille irodu language. It can have either epsilon or irbeku nange. Right? So step 3. Minimum string A, B, epsilon, C. So next I'll draw transition diagram. State 1, state 2, state 3. State 1, state 2, state 3. Right? So I can have n number of A's or nothing. I can have n number of A's. A ಇತ್ತು ಇಲ್ಲಿ accept ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. A ಇಲ್ಲ ಅಂದ್ರೆ epsilon. So only A ಅಂತ ಅಂದಾಗ A ಆಗಿ ಬರುತ್ತೆ epsilon ಮತ್ತೆ epsilon. So this will be your final state. Nothing epsilon accept state. Epsilon. So without input state transition happens here to a final state. So n number of B's, n number of C's. A ಇತ್ತು ಅಂದ್ರೆ A ಇಲ್ಲಿ accept ಆಗುತ್ತೆ, next state ಗೆ ಬರುತ್ತೆ. B ಇತ್ತು ಅಂದ್ರೆ accept ಆಗುತ್ತೆ, next state ಗೆ ಬರುತ್ತೆ. C ಇತ್ತು ಅಂದ್ರೆ accept ಆಗುತ್ತೆ, ಬರುತ್ತೆ. A ಇಲ್ವೇ ಇಲ್ವಾ? So upon epsilon it comes here. B ಇಲ್ವೇ ಇಲ್ವಾ? Next comes to 3 upon epsilon, then it accepts here. C ಇದ್ರೆ ಸರಿ, ಇಲ್ಲದೆ ಇದ್ರೆ ಸರಿ. ನಾವು ಯಾವುದೇ ತಗೊಂಡ್ರು ಇಲ್ಲಿ accept ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So this is a simple example for your Epsilon NFA. Clear? So in the next class we'll try to solve problems to convert your Epsilon NFA to its equivalent DFA. So before that I'll have one recorded class with your explanation of your algorithm that converts the Epsilon NFA to its equivalent DFA. Okay, fine. Thank you. So try to define all the aspects here: K, alphabet, transition, accepting state, starting state. Try to define all these things here. Fine. Clear. Thank you. We'll see in the next class with the in detail problems of your Epsilon NFA to DFA conversion.